still not work. So let me start with just introducing myself. So I work at Cloudera. I'm a solution engineer there. We basically design the architectures for customers to implement their big data analytics platforms, basically enterprise data lakehouses, etc. Right? So the topic that I've chosen today is, by coincidence, I followed a topic that Helen was actually mentioning, is that in her architecture diagram, she mentioned that a lot of sources are there, right? So data coming from everywhere. And she mentioned that all of this data need to be bought in to actually use it. But we obviously haven't discussed how it is bought. So let's discuss that now. So it is bought in using various technologies over a period of last 2 decades. We have seen data evolving from Excel, CSVs to JSONs images today, and it is even going to go further complex because we are trying to optimize the source systems and make them faster. So the need of optimizing these sources and how we store data is also growing. So you keep inventing new and new ways of storing the data, which will make the incoming data more disparate and more diverse, right? So going from CSVs, database records, to today's images, videos, JSON files, XML files, nested JSON files, arrays, etc., etc. So is this working? Okay, so I thought I'll probably do a 2-minute introduction of this slide and explain what are the different sources, but my previous speakers have done that for me, so I'll not spend too much time. The whole point of this slide is to explain that the data that you are seeing today is vastly different based on the field that it is being used. If you look at manufacturing, it is completely different. You rely a lot on the sensor data, the engineering machineries that you have, right? And then if you look at banking, the data is entirely different. And if you look at any other field like hospitals or inventory management, the data is varies depending on the use cases that you actually try to implement with your source systems. So with all of that data coming in, if you think of most of the customers today are thinking of building a large scale data warehouse or a data lake house, where I want to converge all of these into one, right? Into one single platform, bring everything into one single place, so that I can start seeing how one is impacting the other one, or how both of them are impacting my top line. That's the end goal for everyone. People are not doing this for fun, right? Obviously, they're doing it for increasing our top line. So bringing all of this together into one single place is where Cloudera has been investing largely, and we have been you can look at the customer base that we have, or the amount of we are obviously the market leaders in big data implementations, and that is one of the primary reasons why we keep investing, is because the data is the diversification of data is also increasing here. This is my point being the same, right? Now to the point where we have to bring all of this data in. How do we bring it in? We have different technologies today. Obviously, different technologies varying to different sources. Some work very well with structured data, some work very well with streaming data, some work very well with some other type of data, right? Now, how do we make sure you can't obviously start buying everything and then say, for this kind of data, I'll use this tool, for this kind of data, because you will always have to maintain some kind of a process to it, operationalize it, you have to maintain your CI/CD integrations to it. So a lot of things are at play which are being largely affected because your data is like this, right? So now what is a data flow, right? So a data flow is the process of moving data from point A to point B. Simple, nothing else. I want to move data which is coming from my source systems, and I want to store it in my target system, which is probably my lakehouse. Now, if this is the case, if this is how simple it is, you should be able to do it, right? Obviously, it is not. The reason it is not is, again, diversification. You need different treatment for different data sets. Now, while treatment is one of the things, collection itself is a huge thing, you have to collect the data. Now, when it comes to collection of data, you go to any CXO or a data analytics head. If you ask them a question saying, how soon do you want this? What do you think the answer is? ASAP, right? As soon as possible. Now, that is the statement. When it comes to data collection, the sooner is always the better. Now, what is the problem of collecting this data sooner? Obviously, going back to the points, this is going to be very repetitive. So, you have specialized tools which generate specialized data which needs specialized way of collection. And you have edge devices like sensors, GPS locations, ATMs, etc., where you have to do edge collection as well, right? You can't obviously rely for them to collect the data and give you tomorrow. And also, public and private sector data, you cannot treat all data the same way. Even though it is CSV file, a banking CSV file has a different way of treatment compared to a manufacturing CSV file. So there are different ways of dealing, different ways of processing this data, which is actually very cumbersome for both developers and people who are working as data stewards and people who are working as or heading this entire initiative of data collection and analytics and engineering, right? Because there are too many things to take care of. Now, what would be an ideal scenario is you have one single tool taking care of your entire data collection, right? Maybe it has its own way of implementation, or maybe it has some additional processes to do it, or it is still evolving. It could be anything today. But then if this is the case, if all data can be collected in one single fashion, where you are basically standardizing your data collection process across your organization, right? That is the most important point that I wanted to make today. Now, with this in picture, I want to introduce you to a technology called Apache NiFi. You would have probably heard it a lot of times because it is not new in market, even though it is young in the market. So, what it can do, we'll discuss that in detail, but the idea is to imagine this as a centralized core piece of your data collection, and every other source and target routing or receiving data from, right? It could be on-prem, it could be cloud, it could be a streaming platform like Kafka, right? Kafka is emitting data, someone has to read it, so I can read it. So that being the centerpiece, right? Now, when you are, obviously a lot of this also depends on infrastructure, right? Ellen is specifically mentioning how infrastructure is the core piece of how you operationalize your ideas. Without that, you cannot obviously build any of this, right? So, similar to all of that, these processes also depend a lot on infrastructure and how you process data, right? So, we come down to that. This is just for imagination. Now, NiFi is, it's not programming, so relax, you don't have to worry about writing thousands and thousands of code. It is a flow-based programming. Basically, what you do with NiFi is you define, I don't know if you can see, but those small boxes. So each box can be treated as a action. Now, a box can represent a connector processor or a file reading processor, and the other box can represent converting the file into a JSON, right? Following up like that. Now, so that is one of the ways, the only way you can define a flow without actually writing the code. You still have to, like, you do it with other integration tools which mostly support structured data today, right? You have Informatica, you have other tools where you can build similar flows, but they are very well built on a type of data, ideally. Now, what NiFi does differently is it doesn't treat all data, it treats all data the same. That's the difference. What it basically does is, irrespective of whether you are sending database records, images, or CSV files, it treats everything as a flow. Right? So, when the treatment is different, your data that is coming from the source can be made into a flow file and treated as a flow file until it is delivered. That basically simplifies your data diversity. Now I'm sending 1,000 images. I take one image at a time and then start processing that image. You give me 1,000 records. I take one record at a time, process it. Right? Of course, the way you process it differs. You cannot treat the image as a record, obviously. So that differs. But then the ideology behind it is to treat that object as a flow file, irrespective of what it is, and then taking it through the journey that you basically define. Right? You define a journey, point A, and till it goes to point B, you are basically doing some transformations, right? You say, I don't want this image colorful, I want it to make it black and white, for example. So that's a transformation. So you do that, and then you deliver. Now, one of the major reasons why NiFi is able to do this is because we have very strong community. It's an open source application, obviously. And you can make use of it today. You can start downloading it, installing it, and trying things out. It's very simple to use, very easy to set up as well. And then it has maturity over a decade today. So it was launched almost somewhere in 2001 or 2. And it has a lot of pre-built connectors. So when it comes to connectors, they are the core, how do we say this? They are the core brain behind the entire execution. So you have a connector, let's say, I want to convert a JSON into CSV. So we have a connector which basically reads a JSON file, parses it, and then push it out as a CSV record. So this is absolutely important in scenario where your data is being emitted by machinery, right? Or mobile apps, where most obvious choice is to have a arrow-based JSON objects. You just push it out, and then you want to ultimately, when you want to analyze it, one point that I want to make is when you want to analyze it, you want everything to be structured. So you cannot say I will analyze my JSON object. So you want to obviously convert it into a structured format, give it some kind of a form so that you can start making sense of it. Because ultimately it has to be a human to make sense out of it. So we do that. You do a lot of that actually in the real world scenario. So we have built so many pre-built connectors over a period of this time so that you have. Now the other important piece is when you are collecting data from point A to point B and transforming it. Now if someone asks at point B, where is this coming from? Right? What is the source of this data? Is it credible? Has someone touched it in between? Basically, the authenticity of the data also decides whether it is usable or not, right? So we need some kind of a provenance attached to it. So it has inbuilt provenance, where it basically detects where the data is coming from, what transformations have been done, if there is a lookup, what has been it looked up to, right? Some RBAC policies can be set up to see who touched it, who modified it, and all. And then the delivery aspect obviously is very important because we want this to be delivered at the end, right? We want to make sure the data has a guaranteed delivery. Someone should be able to receive it at the end without any failures. See, there are hardware failures, software failures, errors because the data types are different or the structure has changed. A lot of things can happen in between, but the idea is to make sure there is a guaranteed delivery. And then the volume. So the 3 V's of big data, the biggest V is volume, right? Volume basically decides whether your system is resilient or not. So you design the system for 1 GB and you send 1 terabyte, you're gone, right? So basically, we need to make sure, I mean, the same thing can happen here. You design a NiFi to handle 200 MB per second and you are sending 1 GB per second. The same thing can happen here as well. But there are features in NiFi that can stop this kind of a bombardment, right? You can say, I can handle only this much, so you can give a back pressure setting and a throttle setting to make sure your data is not pushed in, it has to wait, right? Until it is so much better than actually failing the flow than keeping them in wait. Now, what does resilience mean, right, in data flows? So this is the actual objective of the topic. So resilience means a lot of things to a lot of people. So some see it as how can I handle failures. Some see it as how can I handle the structural changes of my data, right? And the others, different errors and everything. But on the whole, if you see, the most important part in this entire flow is the data that comes out of it. Is it, the basic idea is does the data have its integrity intact? Is it being made available at the right point in time with the right options that we have set. And then, is it reliable? Without this, no matter how big a data flow you build, how big an integration you build, if the data doesn't adhere to these integrity, availability, and reliability factors, people will not be able to utilize the data 100%. Right? So the whole objective of how can we do this using NiFi. Now, there are a lot of ways to increase the NiFi's ability to process more data. You can put more clusters, you can add servers, horizontally scale it, give it more throughput per second. You can define things like stateful versus stateless depending on the use case, right? So stateful basically means you are storing the state. Now I think I remember someone mentioning a cookieless concept earlier in the session today. Very much similar to that is what happens to a stateful versus a stateless architecture is when you implement a stateful architecture, you basically store the state to the disk or in memory, within the cluster, within the factor that you are trying to address. Now, the stateless architecture becomes where you are saying, I won't maintain the state, let someone else maintain it for me. So that when I fail, I can go back and get the context. Right? So there are two ways to doing it. Obviously, the overhead is that, let's take an example. I go to a gym 3 months, I'm still the same. Versus I go to a gym and then I come back with a six-pack. Right? What has changed? The effort has changed. So if you want some transformation to happen, you need to put that effort in. Right? So when you want that statelessness to be achieved, you are giving it some overhead. Right? So you are putting that extra pressure on the system to make sure you are resilient to that failureness. Right? That is the most important thing. The moment you take a record, you insert the record, it's simple. You take a record, you transform the record, you aggregate the record, you look up the record, you insert it, a lot has changed. Right? So the moment you introduce a transformation, you are putting additional pressure. The moment you say, I want data provenance to be tracked end to end, there is a little bit of overhead. Everything has an overhead. Right? So we have to make sure the use case, does it need it or does it not? Now, there is no point in tracking the entire mechanism when I don't need it. Right? So that way you can reduce the system pressure and make sure it is more reliant to the prone errors. Right? That's one of the ways. Now, active and passive. We all know Kafka. So Kafka is a shelf. I put a book there. I have to put it. Kafka will not take it. Someone has to come take the book. Right? So Kafka is passive. Someone has to insert a record. Someone has to read a record. NiFi is built to be active. It is young, so it wants to be active. It wants to be participant. So it always prefers to go and read the data rather than wait and someone else send the data. Now, if you are designing it to be passive, which is also a requirement in today's world, because there are places where the data is being emitted as events, and we still have to collect and process it. I'm not saying NiFi can't do that, but inherently it is designed to be active in nature. So when you are designing it for passive, you have to make sure that your passiveness overhead is being considered. Because it has to always hold, it has to wait, be active, listen to someone saying it. So that is very important. It's a very important design consideration when you are designing it for event editions. Right? Now, data versioning. Like I said, your flow can have changes in the data. Now, when I am processing with NiFi, I always don't have to mention columns. I can take a file, process, put a file. I don't have to worry about what columns are there inside. Now, if I am not doing that, there could be changes to the structure of the data. Now, my JSON earlier had 100, now it has 150. Right? Now, those changes, even though you don't see it because you're only seeing a file, but are needed. And so someone has to specifically understand or version it so that you know that there has been a change, and when you know that there has been a change, it is easy for you to go back and see from when this change has happened. Otherwise, it will be extremely difficult for you to understand how your data is changing. Right? That is one of the most important things. Now, there are obvious things like queue management and delivery semantics. Queue management, we just spoke about the back pressure, the throttling, right? How you handle more people pushing data in and how much you can handle. Delivery semantics are important in the sense of I should get at least one record out. If I'm sending my data in, now this is something we call it as guaranteed delivery or at least once delivery. There are a lot of different names to it, different architectures you can design. Some people say I want my data to be available in DC and DR at the same time. So dual insert, a lot of different ways you can handle it, but all of these, right, they ultimately end up tied to your use case. Your use case drives how you design a flow, right? That's the most important part. Now, let's talk about the product, right? We have seen how you can design. Now, all of those design aspects, which can be handled from a product point of view, have been handled with Cloudera Data Flow. Now, Cloudera Data Flow is a technology that is available across on-prem, cloud alike. We are multi-cloud, so you can see the same product in AWS, Azure, GCP, right? So you can launch a flow. So the idea why we are doing this across is your data is being generated everywhere, and no customer is available in one place too. Right? So it is important for them to be able to collect data from where they are generating it, rather than asking them, okay, send from Azure to S3, I'll do it here. Right? That doesn't make sense anyways. So that's the important thing. Now, I spoke about edge, but I didn't explain it, right? So edge, how do we do edge? Edge collection. We have something called as edge management, where we deploy smaller containers on the places where we generate data. For example, sensor, so we deploy a smaller, a mini version of the NiFi on the other end, and then have a side-to-side connection. So whenever there is a event emitted there, the edge knows that, okay, I have to send this back to my mother, so it basically sends it back to the mother, right? And then explanation of different processes that you can do, guaranteed delivery, rebuild connectors, and a lot of that. NiFi also comes with the registry. So whatever flows you define, you can push it back to the registry and then collect it back. To make changes, you version it. Someone else is using it, they can version it. So CI/CD integration can be done. A lot of APIs are available in market. I don't want to go too much deep into that, but it is possible. Now, how do you do it in cloud, right? So we have something called as a flow developer. So a flow developer is a no compute way of doing it. So we give you a designer, just like Photoshop, and you start painting your flow there. Now once your flow is painted, you have to decide whether you want to run it in a stateful or a stateless manner, right? Whether you want to run it in a serverless function like a Lambda, right, with functions, etc., or whether you want to run it as actually a flow deployment where I take VMs, containerize them, and then run it. Right? So you can decide based on your use case and then use both those options. Both are natively available. So today, if I want to infer an ML program, I can design a flow and then I can push it to AWS Lambda. Lambda will take care of my execution, where I am designing the flow in data set. That's because I've created a flow designer. So that is how it has been done. And load balancing obviously is done inherently. So by default, we give three backend servers to make sure you have that load balancing and throttle available. So this can be auto-scaled. You can say I can go up to 10, 20, and then whenever your input is growing, the system understands the input is growing, and it will automatically start adding up more containers. So your flow is intact. NiFi can handle both stream, batch alike. Right? You can, like I said, I can read from an Oracle database and start writing it to a Kafka, or I can read from Kafka and start writing it to an Oracle database, obviously. So this is what I was talking about. The flow designer, it basically looks like that, and then you can start putting up your little processes. Each one of them is called a processor, and then you can start saying, connecting them. I can connect. I have one source. I can connect to two targets at once, two processes at once. A lot of these things can be done, and then there are a lot of other mechanisms to be resilient. Like if one record failed, what would I do? Right? So I can push back the record into the same processor so that it keeps trying until it is done. Right? So that can happen. Or you have different retry mechanisms where you can define others like, okay, if this failed, go back into a check rather than retry it. Go back and check if the structure is intact, if the data is up to the quality. Right? You can define all of that. Now you can say if the structure is not intact, you spit it out as an error rather than reprocessing it. So all of those can be defined because it's your imagination that basically drives the flow. Now, I explained this flow just now. So you have a developer, you build a flow, you push the data into, you have a catalog. So you can catalog all of your flows in one place, and then have them like reuse them, collaborate with other people in the teams, etc., and then define between data flow, stateful and stateless kind of a deployment fashion. You can do that. Now, we have also built something called as a ready flow gallery. Most common use cases like moving from Kafka to Kudu, or I don't know, Snowflake to Kafka to Snowflake, for example, irrespective of the technology, what it is being used, because it can literally connect to anything, right? So those are readily available in this thing. So you can take them and then modify it how you want to use. Basically, you are building templates, and those templates can be reused as well. Catalog, I just mentioned about this. So every flow that you create can be pushed into a catalog. So tomorrow, if someone comes out and then says, okay, I built a flow 2 days ago, you have built a flow 2 days ago, can I use it? You will say, yeah, it's available in the catalog, I will give you permission, you can start to and build on top, right? So collaborative way of building it and watching it. Now, so scale, most important question. Can we scale, right? So NiFi has been proven to deal with billions of transactions. Billions, I'm not talking about millions here, billions. Billions of events can be processed, and this is a published law where I think we did it a couple of years ago. So today we should be even in a better situation than this, obviously. So we have, these are not very too big, powerful 100 node clusters. They are hardly 5-10 node clusters, and we are still able to process with throughput. Now the most important aspect of NiFi is it is designed to eat whatever you give it. So you give it a 100 core machine, it will eat it. Right? So NiFi doesn't go with other services. So you should obviously keep it separate. You should not deploy it with your existing applications. It will basically eat all the resources. So you will not have anything. Right? So we have a deployment wizard. So you have a catalog built. That catalog can be deployed in this particular fashion. You can have sizing, scaling, optimize, you can have KPIs defined, you can parameterize it. Sometimes you want to connect to database and you want to give different usernames and passwords or different paths, etc. All of those can be done. Now KPIs, you can define some KPIs like and then say what am I looking at, how much data am I processing, all of that can be done. Maybe detailed documentations are available, it's just for your reference. And we have a dashboard. So each flow that you define will look like this. And then if there is data coming in real time, you will be able to see at the data in real time, and then also see how much data is being sent, how much have we currently processed. All of those information are available as part of the dashboard.